All right, guys. Yes. Holbert, because there's a tournament.
Oh, yeah, the HVAC was going to.
Yep, they're going to go play there and then try to make it back here.
Yeah, that's not that hard. Holy crap, we're weird. Well, the 8th and 9th grade game ain't until 7:30, so.
Yep. All right, guys. Polynomial functions. So this here is just a continuation of what we did before our matrices. Now, polynomial functions, quadratics are a type of polynomial function. We're just expanding out upon it to higher degree polynomial functions. A polynomial is a monomial or a sum of monomials. And this here is just how we can write the general form for any polynomial function that we want. It's just general form. Now, there's 5 types of polynomials that we do have listed here. The first one's a constant. It's degree 0. The reason we call it degree 0 is there's just a number. There is no variable. We can really write a variable if we wanted. We can say 14 times x to the 0, but anything to the 0 power is 1. So it's just negative 14 times 1, which is negative 14. Linear is our first degree because the exponent attached to x is 1. So the biggest exponent's 1. So therefore the degree is 1. And a degree 1 polynomial is linear. Our next one's a degree 2 which is a quadratic. The reason we consider it a quadratic is because our biggest exponent attached to a variable is 2. So it's our quadratic function. Cubics, degree 3. Same thing, we have x to the 3rd, and lastly our degree 4 is a quartic, which is our x to the 4th. Now there's 2 main key types with this here. Standard form, writing the polynomial of order of decreasing power, so whichever exponent has the biggest power goes first, and then we decrease down to our constant term, or just keep decreasing down. The other part is leading coefficient. Leading coefficient is the number with the variable to the biggest exponent, or the number in front of the variable with the biggest exponent or highest power is leading coefficient. Questions on this so far? All right, now we got to define what a polynomial is. And we could go through and try to describe all the things that it is, or we can say what it's not. Exponents aren't negative. So with our variables, we cannot have a negative exponent attached to a variable. So we can't have x to the negative 1 and it be a polynomial function. Yeah. Let's look at this here. So the next thing, exponents aren't fractions, so we can't have x to the 1/3. When we cannot have a fractional exponent attached to a variable. Yeah. Can't have negative exponents. We cannot have fractional exponents attached to variables. We also can't have exponents that are variables. We can't have x to the a or 2 to the x. We cannot have a variable in the exponent. We cannot have a variable as an exponent. Because especially this 2 to the x would be considered an exponential function, not a polynomial function. Variables aren't inside of radicals. We can't have square root of x, cubed root of x. We cannot have x inside of a radical. I'd be writing these out so that you have them, especially to reference back. Mhm. We can't have two different variables being multiplied together. We can't have x times y. That's not going to be a polynomial function. And lastly, variables cannot be in the bottom of a fraction. Not that bad. A radical. Yes, sir. Yeah, because it can be at the top, because x over 2 is the same as 1/2 x. So those are fine. It just cannot be in the bottom of the fraction. Questions on any of these here? All right, guys, focus in. All right, guys. Questions on any of these here? All right. So what we want to do first is look at these here. We want to decide whether or not each of these is a polynomial function. If it is, we want to write it in standard form, state its degree, type, and leading coefficient. So if we look at the first one, negative 2x cubed plus 5x minus 8. So why is it not?
It's not because it has a 2x. It has a variable. It has a variable and a variable.
So does it have a variable as an exponent? So when we look at this here, okay, so we have this. So let's go through the list. Are there any negative exponents? No. No, okay, so that's fine. Are any of the exponents fractions? No. Exponents aren't variables. So there's not a variable in the exponent, okay? Do we have variables inside of radicals for this here? Nope. Do we have two different variables being multiplied together? Is a variable in the bottom of a fraction. So is it a polynomial function? Yes. Because if any of those are true, then it's not going to be a polynomial function. Since all of those are true, it is. Now, standard form, the term with the biggest exponent is going to go first, which is, well, negative 2x to the third power. Now, we would go x squared next, but there's not an x squared, so then we go to our x term and constant term. So this here was already written in standard form. So we really didn't have to do anything to it. The degree. The degree is the number or exponent, the biggest exponent, which in this case is 3. The degree is 3 because the biggest exponent we have attached to a variable is 3. Now the type is cubic. Because if it's a degree 3, it's a cubic function. And lastly, leading coefficient. Leading coefficient is the number in front of the variable with the biggest exponent, which is -2. And that's it. Questions on A before we look at C? We good with A? Let's look at C. -2 or -x squared plus 7x to the -1 plus 4x. Is this a polynomial function? No, because x to the -1, we have a negative exponent, so this is not a polynomial. And since it's not a polynomial, we're not going to put it in standard form. State the degree, type, and leading coefficient.
I don't think B is either.
So B, let's look at it. Why would it not be a polynomial function?
Isn't it? Because it has one of the
The square root. Now I would agree if that radical was a little more extended out. But right now, yes. But because, and we'll get to D here in a second, because that radical stops just at the 2, the x is not inside the radical. So G is actually, yes, it is a polynomial function. G of x. In standard form, we'd have the square root of 2 times x to the 4th, because if that x to the 4th was inside the radical, then yes, it would not be a polynomial function. But since it's on the outside, that's fine. Then we have minus 0.8 x cubed minus 12. Now what's our degree? 4. And the type is quartic. And the leading coefficient is almost. What's the number in front of the term with the biggest exponent?
radical.
Square root of 2, radical 2. Questions on the first 3 we've done so far? All right, let's look at the last one. X squared plus 3 to the x. Is this a polynomial function? No. Because? Because we have 3 to the x. 3 to the x is our exponential functions. So no, it's not a polynomial function. You can. Question on any of this so far? Let's look at number 1. 7 minus 1.6x squared minus 5x. Is this a polynomial function? Yes. So if we wrote it in standard form, our x squared term, because it's the variable with the biggest exponent, would go first. So we have negative 1.6x squared. Our x term would be next, so minus 5x. And our constant term of positive 7 would come last. Now what would the degree be? The degree would be 2, which means it's a quadratic. Leading coefficient, negative 1.6.
Okay, bro. We're not being smart, but I don't know where
All right, guys, let's look at number 2. X plus 2x to the negative 2 plus 9.5. Is this a polynomial function? No, we cannot have a negative exponent attached to a variable. How do we feel about these here? All right. Let's move on to the next part of this here. We want to evaluate f of x equals 2x to the fourth minus 8x squared plus 5x minus 7 when x is 3. So if we're evaluating this when x is 3, all that's telling us to do is replace every x with 3. Now you just need to plug this into the calculator if you want and simplify this here.
You're probably gonna score like a 30 on the ACT. That's good. I don't know that's good. That's what I'm saying. I wasn't dissing him. I'm giving him a compliment. 102.
I think it's a little under that.
I wish that had ACT taught you.
Let's see.
Yeah, what up, Ray? Oh my God. Hey, Ray. Every day you learn that Disney Channel.
Okay, that looks good. So scroll enter. That's it. Minus 7.
Oh, okay.
Yep.
My brain didn't brain everything.
You're good. Questions on how we got this here? Questions on how we did this here?
That's my dead on.
All right, guys. Let's do this one here. This time we're going to replace every x with 4.
Yeah, bro got hit by a drunk driver, man.
All right, guys.
I can hear the rain now. You hear that? That's really bad. That was rain. I think it was. You go with my good. I got negative. I actually went on. Oh, that's why Princeton's like, I don't know. You want to go to college? I'm not going to see that. Yes, you are. I just don't want to get off on one. Oh, I've got to do this.
All right, guys. Questions on evaluating? Now, I do need to be careful with negatives. We need to make sure we put parentheses around it, because without them, especially with x to the fourth, it would give you something different. Negative 90. Questions on this here? In behavior. Last thing we're going to look at today is in behavior.
I've seen an infinity sign, so I'm scared. Yeah, that infinity sign do get you scared. I don't know about it. No. Well, you know my favorite play? The one with 4 points. If I was in there, I would have scored like 200. The one I made it. I would have.
All right, guys. Now the degree. All right, guys. So the degree of a polynomial function can be one of two things. It's either going to be even or odd? Yes, sir. I mean, this is going to be the same thing as this here. You're good. Because the degree can be one of two things. It's either going to be even or it's going to be odd. Now, the other piece that we have is the leading coefficient. Can either be positive or it could be negative. So, and this here is kind of describing the end behavior, because polynomial functions, where you see the dashed line on all these here, what happens in the middle of these here, for each of these types of functions that are even and positive, even, negative, can change. They're going to be different, but eventually it's going to behave the exact same way every single time. So if we look at, say, even degree polynomial functions, eventually they're all going to open up or down. And if it's even and positive, eventually, no matter what happens here in the middle, it's eventually going to go up. The two ends are going to go up. At some point, they're both going to go up. If it's even and negative, the two ends, the end behavior is going to go down. So if we said it's an even degree and the leading coefficient is positive, then our f of x is going to approach infinity as x approaches negative infinity. As we plug bigger or smaller and smaller numbers into the function, the y value eventually will get bigger and bigger and will go to infinity. And f of x will go to infinity as x approaches infinity, positive infinity. Now, if it's an even degree and the leading coefficient's negative, well, f of x is going to go down negative infinity as x approaches negative infinity. And f of x approaches negative infinity as x approaches positive infinity. And with our odd functions, we will have a similar case. As x approaches negative infinity, positive infinity as x approaches positive infinity. All right, so let's look at this first one here. So we want to find the end behavior of this here. Now, what is the degree? Degree is 4, which is even. Leading coefficient, negative 0.5. So it is negative. So if we want the end behavior, we can come over to this chart. So we have even and negative. So this here is our answer. So what we're going to say is our answer for end behavior is that f of x arrow approaches negative infinity as x approaches negative infinity. And f of x approaches negative infinity as x approaches positive infinity. And that's it.
The only thing I can draw for the two side without handling is a diagonal.
That's fine. Yes. Yes. Questions on this here? We're ready for the next one. So if we look at this one here, the degree is what? 3, which is odd. Leading coefficient is Negative 0.3. And the main thing we're focusing on is the fact that it is negative. So we're looking at odd and negative. So if we go back to the chart, odd and negative will tell us that f of x approaches positive infinity as x approaches negative infinity. And f of x approaches negative infinity as x approaches positive infinity. And again, we're just pulling that data straight from the chart. Questions on this here? Yes. Because there's a lot to it, but not a lot to it all at the same time. Because again, this gives us an idea of what the graph is going to do or how it should behave. Because we know that this here, the y value should be going in opposite directions. One's going to positive infinity, one's going to negative. And this is not the graphic of it. But if we had this odd degree polynomial function, and we know that it's going in opposite directions, and what our screen, our graphing calculator told us was this, well, we know that one of these two endpoints has to be going in the opposite direction. Yes, sir. Y equals? Put that in there. We ready for the last one? This here, the degree is 3, so it is odd. Leading coefficient is 0.25, which would be positive. And if we referred back to the chart, it would tell us that f of x approaches negative infinity as x approaches negative infinity. And f of x approaches positive infinity as x approaches positive infinity. Kind of gave you an S, sideways S.
Yeah. Very elongated.
Yep. That's it. All right, guys. Yep.
My home, my other homework was satisfied.